do that, I'm going to use a lot of graphics, a lot of data, a lot of maps, and I think it will tell a very compelling story about climate ecology interactions and what we can expect in the future. But also, I think the data sometimes doesn't capture the soul of this place we call the North Woods and the landscape ecosystem such as the Boundary Waters. So I'm going to do something a little different, because I'm going to start with a 3-minute slide presentation. Okay? This is kind of my personal portrait of the North Woods based on my experience up here since 2006, where I took photography on as kind of a hobby. Okay? And so I'm trying in this brief 3-minute slideshow, without me saying anything, just to try to communicate what an extraordinary special place the Boundary Waters in the North Woods is. I mean, I grew up in Illinois, and even the concept of a cold water lake, they don't have any in Illinois, as an example, okay? They don't have any large, primeval, native ecosystems like the Boundary Waters. So this is really an extraordinary place, and so I wanted to express it a little bit. So you'll see on the slides kind of my attempt to show you some of the plant associations, some of the trees, some of the life forms, some of the ecological bonds and interactions. And I'll just say up front, a lot of things that you're going to see are going to change in the future. Many of them, the populations or the interactions are going to change quite a bit. Other things may actually increase, and some things we just don't know. But at this stage, from what we know, it is almost implausible to think that the Boundary Waters is not going to change and the North Woods isn't going to significantly change. The only question is, how different is it going to be? Is it going to be something different and something less than what we have today, or is it going to be different but still maintain a certain ecological integrity and diversity, and I will also say beauty? And I think we can have the latter if we do two things. One is we're going to have to manage our forests in a different way. I'm going to talk a lot about how we can manage our forests and make them more resilient to a changing climate. The other aspect that I'm not going to talk about much, but is equally, if not more important, if we don't significantly curb the climate warming greenhouse gases into the atmosphere, then we will have a different North Woods and something that is much less than what we have today. So with that, let's watch 3 minutes. patience with that. And now you know a little bit more about me because I have an inordinate fondness for a Canadian singer-songwriter, so it's Neil Young. Okay, now on with the show. Okay, again, we're going to talk about climate trends, both observed and projected. When you talk about climate, at least to me, there are kind of two branches of science. The observed, the documentation of what we've already observed, and then how we can project things using models in terms of what the climate may look like. I'm going to spend a lot of time on the observed, because I think often when people speak to climate change, it's like it's something far distant into the future. Well, climate change has really invaded every part of our lives now. Obviously, we've been through a quite brutal summer across the whole planet with historic wildfires and droughts and floods and heat domes and first ever rainfall on the ice caps of Greenland. So it is kind of a moment of truth, I think. So I'm going to talk a lot about the observed. And then we're going to talk about how those climate trends are driving the ecology of our forest, what we've already observed and what we may expect to see by the end of the century based on models. And then finally, I'm going to talk about a path to resilience, and that is the kind of on-the-ground forest management and restoration we can do to help our forests be more resilient to a changing climate. Okay, next slide. I don't want to get into a lot of details here. I just want to make 2 points. One is there are a lot of feedback loops when you talk about climate and the ecology. And then the other thing I want to point out is, you know, there's a direct influence of climate on tree distribution and composition, but there are also indirect, compounding influences that I really want to get on today. So it's not just a warming of the climate, but how does that warming affect wildfires? How does it affect insect outbreaks? How does it affect extreme weather events? So I want to talk about all those relationships. Next slide. Okay, here's your take-home message on the climate. Okay, here's what we've observed in the state of Minnesota. And right up front, I want to acknowledge the DNR's climatology office. That's a small team in the DNR housed at the university, and they just do phenomenal work in climatology. So if you go to the DNR website, type in Climate Explorer. That's where I got a lot of this data, and you can use that to do a query. You can put in any scale you want, state, watershed, region, and ask any question you want. What's the history of droughts in Minnesota since 1895? For my particular watershed that I'm in, what are the precipitation patterns between this date and that date? And we'll spit you out a really nice graphic. So it's really a great tool. Okay, so here's where we are. Annually, Minnesota is getting wetter and warmer. That is now an established trend. Okay, and that's projected to increase through the end of this century. Winters, shorter, less cold, more snowfall, but less snow cover. And I'm going to get into the detail of all of these because these are all extremely important because the climate really drives the ecology. The third one, in summer, fewer cool nights, but as you know, more frequent and heavy downpours, these extreme events. And projected for the future, well, quite frankly, a lot of surprises. Right now, there's not a really good climate signal between climate change and drought, if you look at it very closely. In terms of the aerial extent and the frequency of drought, we don't have much of a signal here in Minnesota the way they do out west. Now, in the future, we're projected, but right now we don't see a big signal there. Okay, next slide. You can hit it again. So let's look a little closer now. So here's the annual average. Now, the first thing you're going to recognize is Minnesota is a northern latitude state. And the higher you are in latitude, the more climate change is going to impact you. And so you can already see the gradation here from the south to the north. So since 1895, we've had a 3.5 degree temperature change up here in the Northwoods. Okay, next slide. Now, this is what's really the most striking to me is the winters. So again, you see a gradation from the south to the north, but in the Northwoods, it is 7 degrees warmer in the winter than it was in 1895. And then when you look at the summer highs, this is a very interesting one because there hasn't been that much change. You look at northern Minnesota, about a 1.1 degree increase. But if you look at the summer highs in the southern part of the state, and it's actually decreased a little bit, which is not all that surprising because as it gets wetter, that tends to dampen the heat a little bit. Okay, next one. Now this one looks kind of complicated, but it tells, I think, a very important story. So I wanted to put this one up. The middle part of the graph is the 20th century average in annual precipitation and the annual temperature. And what the climatologists did, all these ones here that have dates, they took the top 10 combined wettest and warmest years. And as you can see, they're warmer and wetter, all these 10 years. And all of these have occurred since 1999. So in the last 25 years, we've had the warmest, wettest weather since 1895. So we've got an established trend here. Now, if you look at the wettest year, which is 2019 here, way up here, you just look at the deviation from historical averages. It's pretty amazing, but it wasn't a warm year. It was a little bit cooler. Okay, next slide. Now I'm showing this map. This is a drought index map. This is 1987 to 2013. And with everything I just said, well, it's getting wetter and warmer. Why are our northern forests under drought stress? And one of the important things about trees and most species is that they're very sensitive to their local microclimate. They don't care what the averages are. So in the case, the reason why we've been in a drought in Minnesota, there are a couple reasons for that. One is getting wetter more in the south than it is in the north, but also it's a distribution of that rainfall over the growing season. So we're seeing wetter years in the north, but wetter in the winter and in the fall, and having periods of being quite dry in the summer. So when you don't have that even distribution of rainfall, your trees can be stressed and they can be in a drought condition. And then also, let's also remember that as the air warms, that trees are evaporating and there's more transpiration. So that offsets a little bit increase in rainfall. Okay, next slide. Here is the loss of cold extremes across Minnesota. And again, this is really pretty remarkable. This is in Grand Rapids. This is the count of temperatures that were less than 35 degrees below zero. Okay? You see what the trend is. It's amazing. Now, if you think about a lot of what I'm going to talk about are tree species, and in the boundary waters here, historically it's very common to have temperatures 40, 50 degrees below zero. And if you're a temperate tree, like a red maple or a red oak, 40 degrees below zero is going to kill the cambium layer of the tree, and the tree's going to die. But when you start eliminating those cold temperatures, those trees are going to be able to invade the northwoods, and we're going to talk more about that. Or if you're an emerald ash borer, if it's 30 degrees below zero or more, that's going to kill 98% of that particular beetle that kills black ash trees. So a lot of our species that historically were native up in the north woods were here because of that cold barrier that kept insect invasions out and kept other trees that are less adapted to cold weather, but they're much faster growing than our northern trees, who use a trade-off. To be cold hardy, you grow slower. And that's fine when it's below 35 degrees, but when it's not, then you don't compete well with other trees. Next slide. Snow depth. We're getting more snow and more precipitation. But if you see these bars here, the average snow depth from November to March is declining. If you look at the more details, the snow depth that's 6 inches or less has declined by 25% since the 1950s. The snowfall 12 inches or more has declined 35%. And then at the very bottom, you see the number of days with no snow cover. And that has increased by 63%. Now, if you're a rough grouse and you live up here in the north woods and you have to bury yourself under a deep fluffy snow to insulate yourself in winter climate, you're going to have a survival problem because you've got shallow snow and you've got hard frost on that snow. That's just another example why this weather is so important. Next slide. Okay, now you've all seen the Minnesota biomap before. This is where the coniferous zone is. This is the eastern broadleaf forest and then the prairie. And one of the things about our state, because we have these transitions between these major biomes and they're so abrupt. So if you're in the Twin Cities, down here, the distance between the eastern broadleaf, the climate between eastern broadleaf forest and being up in Duluth here is about 3.7 degrees Fahrenheit. And so it doesn't take much of a change to actually shift a biome, to go from a deciduous forest biome to a conifer biome. Next slide. So, what happened to that one? That's fine. So I just want to give a couple examples to talk about these direct impacts of warming and then these compounding impacts. And the one that is real close to my mind is the nature of red maple in the forest. When we bought our cabin in 2006, one of the things I noticed as I walked the land, there were a lot of red maples that were marked with red ribbons. And so I talked to the landlord and said, well, why are you marking those red maples? Because of course they're everywhere on our property now. He said, well, back in the 80s when we bought it, they were so rare that I tagged each red maple so that I could protect them. Okay? So now, in 2006, when we bought our cabin, you would see red maples really quite abundant in the understory. But there wasn't really any maples above 6 feet because they frost crack and die. Now, if you come out to our property, I'll show you red maples that are 40 feet tall and they're not frost cracking. And so the maples are moving into the boreal forest. Next slide. I want to point out some really interesting research that the University of Minnesota is doing there. The Department of Forest Resources with Leif Greylock, Peter Reich and others are just doing some remarkable research on ecology and climate. And I like this one in particular because it shows that direct impact of warming on forest ecology. So this is the boundary waters going from west to east. That's down 150 miles along the Canadian border there. And what Dr. Freilich did, he put 106 temperature sensors in a long transect across this area in order to measure what the average summer temperature was. And what he found going from west to east is there's actually a gradient of 12 degrees Fahrenheit of difference from the west to the east. So they established that. And then what his graduate students did, they walked that long transect and they counted every temperate tree species in the woods, because this is true boreal forest. We're talking about spruce and tamarack and balsam fir, aspen birch. And that's what these red dots represent. And those are red maples. So they counted all the seedlings and saplings. No canopy trees there at this point. And so you can see there's a perfect correlation between warmer temperatures in the west and abundance of red maple, and then tallying on as you go to the east. And one of the things to note about that, you can almost see that on this map. You know, obviously we have a lot of lakes in the Boundary Waters. I think it's over 100,000 lakes, small lakes including. And what you'll notice in the eastern part, a lot of the lakes run in the east-west direction. And when you do that, you're cutting through the topography and creating a lot of steep north-facing slopes. So you get this microclimate there where it's much cooler there than on a south-facing slope. And also those are deep lakes, and so you get an upwelling of cold air. And so the microclimate is extremely important. And one of the things that this tells me, you know, when you project out towards the end of the century, a 5-6 degree change in temperature is within the range of what we're going to expect, even if we make significant progress on curbing greenhouse gas emissions. So if this area warms up by 6 degrees, I think we can expect we're still going to maintain a lot of our boreal forest, because we have it in this part of the Boundary Waters where it's a lot warmer. But you may see the boreal forest begin to be co-dominated with red maple and red oak. But when we get to this end of the Boundary Waters, we may see a significant loss of the boreal forest and see that area become colonized by red maple, red oak, basswood, and other trees that historically were way to the south. Next slide. Okay. Now I want to talk about not just warming, but how the warming impacts other factors, both biotic and abiotic. So here's a case of tamarack forest, and this is a native beetle called the eastern larch beetle. And historically, it's coexisted with tamarack for almost 10,000 years. And the outbreaks historically have been between 1 and 3 years. So really have very little impact on the ecology of that tree. Next slide. Since 2001, we started an eastern larch beetle outbreak, and it has continued to today, since 2021. So we've had a 20-year outbreak which has impacted over 800,000 acres of tamarack. I think this is an underappreciated story because tamarack doesn't have a lot of market value, but it's a pretty profound change in the forest. Now the beetle is killing mature trees, and the one silver lining is that we still have regeneration of young tamarack forest. How much that's going to hold in the future is hard to say. Now, what was discovered in around 2012, there was some bright entomologists at the University of Minnesota studying that beetle, which is a relative of the mountain pine beetle, which you may be familiar with out west, that has decimated tens of millions of acres of pine trees in the Pacific Northwest. Studying the beetle, what they discovered was climate change, the lengthening of the growing season, and the warmer winters stop a signal to the beetle, and instead of producing one generation in the growing season, is now producing 2 generations of beetles. And that's just enough to overwhelm the natural defenses that the tamarin has. So it's an important story that is not just about the warming, it's how warming affects other things that can have a tremendous impact on our forest. Next one. And of course, I have to mention fire. I don't want to spend too much time on fire because I think you're well up to speed on fire. But clearly, the research, particularly up in Canada and the boreal forest, we know that the fire season has expanded by a good 2 weeks up in boreal Canada since 1957, as an example. And the severity of the fires are increasing as well. And we can just look at some of the fires that you're all aware of in 2006 to 2011, the Cavity and the Pagami. And as Jim knows better than anyone, whenever you look at the after-action reports of these fires, there's always a weather link there. So you're at the Pagami Creek fire, and they've got all their models out there, and it's modeled that, okay, with this moisture level on August 18th, it will probably be 30% because historically it's never been below 30%. Well, on the day that fire got out of control, the humidity plummeted to 18%. And so we're going to see more of those kind of surprises. And we're going to have to be rejiggering our models a little bit, not just to be based on what has happened in the past, not just taking the worst case scenario in the past, because climate change is changing all that. And I also noted that, I say 2012, I meant 2021 there. Apparently that is a state record now for air quality alerts due to the smoke we've had this year. Okay, next one. Now let's talk about climate change and these extreme weather events, the 100-year flood. And this obviously we're seeing all around the world, the 100-year flood, the 500-year flood, the 1,000-year flood. And the climatology office put this together. I think this is a really important one because it's kind of confusing how you chart these 100-year floods. And what a 100-year flood is basically where you have more than 6 inches of rainfall in a 24-hour period over 1,000 square miles. And that's what 100-year flood, which means there's like a 1% chance of having that. 1,000 year would be a 0.01% chance of having it. What I like about this chart, he only took data for the 38 weather stations we have in Minnesota that are long-term weather stations that have more than 100 years of data. So we know this is very accurate. And if you look at that, there were no 100-year floods prior to 1952. They all occurred from 52 until today. And then the other thing to note about this, look at the frequency change. You know, it's broad, it gets narrow, 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 and now we're in an era where we have these so-called 100-year floods every couple of years. Next slide. Here's the big one that you all know about from 2012 in the Duluth area. In St. Louis River, record crest of 16 feet. It rose 10 feet in 24 hours. It washed out one of the bridges there in Jay Cook State Park. Next slide. Well, there was in 2012. Here it is in 2016. 4 years later, almost the exact same area in another 100-year flood. So the 100-year flood it doesn't happen every 100 years. There's a 1% probability it can happen at any time. And what we're seeing is that these things are happening one after the next. Next slide. Okay, now I'm going to shift gears a little bit. I just want to go south to an area called the Big Woods, which is our temperate deciduous forest, because I want to make 2 points. One point about shifting biomes, because when you look at our biome models and you look at the projection of the climate, our climate up here where we stand now is going to more closely resemble the Big Woods forest in the future. No matter what we do, even if we stop all carbon pollution immediately, there's enough baked into the system for the next 30 years that we're going to see some dramatic shifts in climate. And then I just also want to tell a story about how difficult it is to protect forest in a fragmented landscape. The advantages we have up here is we have continuous forest, and so the forest is much more buffered against change. So here's the original Big Woods forest here, about 2,000 square miles. We have less than 2% of that landscape in forest. This is all basically corn and beans now. We've got a few fragments, and I want to talk about this area down here, which is Nerstrand State Park. Next slide. So this is what Nerstrand State Park looks like. And quite frankly, this is a lot of what northeastern Minnesota may look like in the 2060s and in the 2070s, depending on what we do to curb greenhouse gas emissions. Next slide. Now, something very interesting happened I wasn't aware of until last spring when I went down to Nerstrand Woods. It's a beautiful woods. If you've ever been in the Smoky Mountains to see the spring ephemerals, the trout lily, the Dutchman's breeches, the spring beauty, you don't have to go that far. You can go to Nerstrand Woods. It's just an incredible hot spot for spring ephemerals and biodiversity and human populations. It's a beautiful place. But when I went down there, I noticed there was big patches where the forest was completely dead. All the canopy trees were dead. And when I got back and I called the DNR and some of the forest health people, the parks people, and this is the story. And they lost about 200 acres of forest, and there's only 1,600 acres of forest there. And the only thing that is coming up now is green ash. And that's a whole other story because the emerald ash borer is about 20 miles away from the park. Okay? And what is happening in the flat, more poorly drained areas, the trees are getting flooded out. They can't survive there. So let's go back to the climatology. One more slide. We asked the climatology office for that weather station right near the park, what's going on. And here's what it is. If you look at the annual precipitation, the blue bars here, there's been a 19% increase in precipitation on average. And in the growing season, 16% increase in precipitation since the 1990s. And then the other one to look at, and I kind of mix this up a little bit, the bars actually. Here's the precipitation annual and growing season, and the bars are the increase in daily 1-inch rainfalls. So we're having a lot more heavy rainfalls. So when you combine that all together, you pretty much have a smoking gun. It's the wetter growing seasons and the 1-inch rainfalls are pooling water around these trees, and they cannot survive in that kind of environment. Next slide. So one of the things they're doing at Nerstrand, which I'm going to talk a lot more about when we get to the right woods, is Okay, how are we gonna maintain forest in the big woods if all the trees are dying due to increased precipitation? One of the things they're doing is something we call assisted migration. That's where we have tree species that are within the range, in this case the park, but historically they're very uncommon, but they're more adapted to having wet feet. Species like swamp white oak and hackberry. The University of Minnesota has a disease-resistant elm now they want to do trials with, and so they're bringing these under very much trial experimental conditions into their strand woods and seeing if they can successfully reforest those areas that are dying because it's too wet. Next slide. Okay, now we're going to shift to the boreal forest. The boreal forest is really the largest forest ecosystem on the planet. It is circumboreal, which means not only is it across all of North America, but it's across all of Russia and Siberia. And it's probably the largest carbon sink on the planet. Okay? So maintaining that forest, you're mitigating climate change in and of itself. And there's more carbon bound up in forests and forest soils than there is currently in the atmosphere or all the carbon in the ocean. I mean, forests are incredible pools of carbon. And we're at the very southern edge of the boreal forest. Some people call us the semi-boreal. You know, leaf rayla contends the true boreal contains the boundary waters and far northeastern. But the bottom line is we're part of a massive local forest system that's probably the most important forest for storing carbon. Next slide. I just want to set a little context because as we try to prepare our forest for climate change, we got to go back in history and recognize how much our forest has changed since pre-settlement conditions. This is what it looked like in pre-European settlement, and this is what it looks like today. Now, I don't want to get into the details outside to say you can see how much more complex the spatial patterning is here and how much the composition has changed. During the Great Cutover period, 1880s to 1910, when the loggers came in and basically removed all the upland tamarack. Anyone seen an upland tamarack forest? Or if all your tamarack forest been in logs? Well, at one time, tamarack was the most abundant tree in the state, and it was all over the uplands. Now it is basically extirpated from the uplands. White pine, white cedar, white spruce, all the long-lived old-growth trees were basically removed from the forest, from the northern forest. And then when the splash fires came in, particularly in the 1920s and 30s, you basically destroyed the seed source of a lot of those trees. And you ended up with a forest of young aspen birch. And that's what that light green is. So quite frankly, we have a very degraded forest, a very compromised forest today than what we had in the 1800s. And so that means that if we're going to be more resilient to another stress, climate change, we had better bring back some of the complexity in the composition, the age structure, and the spatial patterning of that forest. We want to sustain species like moose. We better have really large spatial patterns. You cannot have moose on a landscape of this kind of climate when your forestry practices harvest 40 acres at a time, or you do a prescribed burn 100 acres at a time. You need big patterns, big habitats. Okay, next one. I just want to give you a couple examples of what I mean by how much the forest has changed. This is white pine. Here's the historic change of white pine. The bright red is where we've had a 5-fold decrease in the abundance of white pine. So that on the next slide. So I want to tell a little story about white pine because it's the one conifer along with white cedar that is really a temperate tree. So it's quite capable of responding very well to a changing climate. So if you look at all the green here, whatever lime green this is, and this is the distribution of red pine and white pine where they overlap. Red pine is, extends a little bit farther out than white pine, but red pine is this narrow band here, but you see the white pine extends all the way down into the Smoky Mountains, okay? So just by warming alone, it's an ideal tree to reintroduce that tree and get that tree back into its historic proportions. And if you're really a tree geek, which I don't know if any of you are, notice some notches down in the highlands of Mexico and Guatemala. That is a variety of white pine. So if you go to the next slide, this is in Guatemala, and Yersinia and I were down in Guatemala in 1991 with the Nature Conservancy on a field trip. And this is Sierra de las Minas, and they have 10 species of pine there, including a variety of our white pine. So apparently, there are two centers of evolution for white pine, one in the temperate Americas and one in the tropical areas. So a really fascinating tree. Next slide. Okay, now I'm going to get into some of the research, inventories, and tools that we're using to inform how we do climate-informed forest management. Next slide. One of the things I just want to point out is we're very data-rich in Minnesota when it comes to ecology, and this is just an example of the Minnesota Biological Survey, which is pretty much a complete index and assessment of the remaining native plant communities and plants and animals of the state. And you can just see here the red areas are areas that have high and outstanding biological diversity. And so you can see our whole North Woods and the Boundary Waters in the areas a real hot spot for biodiversity. And you'll also see down in Rice County where Nurse Grand State Park was, that little fragment down there. Okay. Next one. The other advantage that we have something called the North Woods Climate Change Response Framework. This is a national effort and has a special focus on the North Woods and conducting vulnerability assessments and providing a lot of tools and sponsoring pilot projects. So next slide will give you a sense of what they're doing. One of the interesting things they do is they have these, what they call the climate change triads. And this is their models where they can take a lot of different data and project suitable habitat out into the future. So we talked about white pine. Here's the current distribution of white pine. And then we can take two scenarios. The top one is that if we dramatically lower greenhouse gas emissions and we keep the climate from not exceeding a 6-degree Fahrenheit increase, this is where suitable habitat for white pine will be. So it's projected to do quite well. Even under a high, this is basically the business as usual. If we do nothing to curb greenhouse gas emission, we'll have about a 10-degree Fahrenheit increase in temperature. So you can see white pine is projected to do quite well. And again, this is not where white pine is going to be. It's basically projecting that there'll be suitable habitat. So we'll have to do major work to actually find white pine to get it there. Next group. And don't get fooled by the graph here. I was supposed to change the colors so they would pop out more, and I ran out of time. Anyway, now let's look at the projections for some of the temperate trees. I mentioned the northern red oak. You see what its current distribution is, right smack dab in the eastern deciduous forest there. But look at where it goes under a low emission scenario or a high emission scenario. So it obviously does would do quite well up in northeastern Minnesota. Next slide. And there's our red maple. Again, the same kind of thing. It's found in terms of a seedling or a sapling in the north woods, but in the future, it is projected to be a dominant tree in the north woods. Next slide. This is some work by Peter Wright. Pretty novel experiments they did out near Cloquet and in Ely, where they actually took large tents and heated up the soil and the air with infrared lamps and heating cables to mimic what that warming would look like. And one of the things you notice here, we're probably at like 47.5 degrees latitude, where we are right now, right in Moraines. And you can see the boreal forest, which are these trees here. That latitude is a very southern trailing edge of the boreal forest. And the temperate species, the white pine, the burl, sugar maple, red oak, they're on the very northern edge of the range. And then next slide. Just keep on, one more. Oh, back one. And their data that's all in now is basically has shown that the seedlings of the temperate species have all increased, where all the boreal species have all decreased in those experiments. So we're basically seeing a shift in the temperate biome into the former latitude of the boreal species, and the boreal species are beginning to migrate out of the state. Next slide. So, the take-home message, we're hitting a tipping point here of a biome shift going from the temperate forest to the boreal forest, because the growing season is expanding under a changing climate. Mean annual summer temps are increasing. The cold extremes are declining. And the temperate trees that are adapted to a warmer climate, but they have a fast growing strategy, are out-competing the boreal trees that are very cold hardy, but they're very slow growing. And so the balance is starting to tip. Next slide. So what are we doing about that? I want to give you a couple examples of some of the work that the Nature Conservancy and other partners are doing up in the North Woods. This is an example where they've been looking at areas along the shore and then areas inland. And on 2,000 acres, they've been, why don't you go to the next slide? I'll get this right away. They're applying what they call a conifer stronghold strategy. That is, they're identifying the places in the North Woods where the microclimate is such that they feel that these northern conifers can persist into the future. And so that's where they're going in and they're reforesting the boreal trees, particularly the conifers that were removed in the 1800s, early 1900s. And then they're going into areas where on south-facing slopes and other areas where it's going to be too warm for the boreal trees, and they're intentionally planting temperate forest species, so that the forest is going to be more resilient to that changing climate. Next slide. And so on the conifer stronghold sites, they planted 158,500 conifer seedlings already, and they have a monitoring program, and they're monitoring the success of those seedlings. And again, why don't you go to the next slide, because I'm going to be running out of time. I just want to say how important landforms and geology is to the biodiversity. Okay? And here's where we are now, where you have all these boreal conifers, and in a diverse landform where you have both north-facing slopes and south-facing slopes, your sugar maples are going to be confined to the south-facing slope, where it's a lot warmer. And they're going to be 12, 13 degrees warmer on the south-facing slope. So in the future, you may have a system where the North Woods is going to have a lot more sugar maple, but you're going to keep your boreal trees in the lowlands where you have cold air pockets and on the north-facing slopes. If you don't have that kind of diverse landform, you can have a shift from one biome, boreal conifers, to temperate trees, wholesale. But next one. We're very fortunate because we have these very complex landforms with a variety of microhabitats. And if you're smart about where you plant things and how you manage the forest, we should be able to maintain those species. So this is the other strategy, the assisted migration strategies, where we take these temperate trees, bur oak, red oak, and we're getting seed sources from farther south, and then we're getting those that are farther north. So they're just different genotypes. And we're planting oak seedlings in these areas. And all these areas have been just recently harvested, and so it's an opportunity to replant them to be a more diverse, resilient forest. And so far, they've planted about 110,000 oak seedlings. Okay, next one. And then they have a monitoring program, and this is just one example of those temperate trees. On average, 93% survival of those temperate trees being planted in the boreal forest. So apparently, success there. Next one. And I just want to give you a broader perspective of what the Nature Conservancy and others are doing. To date, they're working in the North Woods. They've been planting on about 25,000 acres, and since 2005, they've planted over 5.5 million trees. And their goal is by 2025 is to plant another 4 million trees. And that's part of a global initiative to plant 1 billion trees. So there's just a lot of work going on there. Next slide. Give you a few quick examples of some of the other things we're doing in the woods. Next slide. Whenever I'm hiking on the North Shore, I always get asked this question: what's going on with the birch trees? Why are they all dying? And I think you probably know the answer, but just as a summary, birch and aspen were not that common on the historic landscape on the North Shore. That was white cedar, white spruce, white pine, balsam fir, the long-lived conifer species. It's only after those conifers were all logged off and the slash was burned and destroyed the seed source did these fast-growing aspen and birch start really to colonize and dominate the shore. So part of the problem is, first of all, you have boreal trees, aspen and birch is boreal trees. They do not like warm climate. The other thing, these are short-lived trees. I mean, birch is 70, maybe 90 years old. And birch in particular, there's a lot of work that Lee Freilich has done. They don't like warm soils. So you've got thin, rocky soils there. You have a duff layer that insulates the roots of the birch, which about 90% of the roots are in the top 3 inches of soil, believe it or not. They don't go much below 24 inches. And you've got exotic earthworms that are eating the duff layer, exposing the mineral soil, that raises the temperature of the soil up at 4 to 5 degrees. And this tree gets stressed. You get a beetle that attacks the birch, and you combine all those things, and all the trees are dying. And so you see what that looks like, and there's simply not enough mature conifers out there to naturally regenerate that. And so now you've got shrubs, a native grass called blue giant grass, which is a sod former, and almost nothing can grow in there. Next slide. So there's a big collaborative now. It's this cross-ownership group of private landowners and the county and the feds and DNR and Nature Conservancy, and they have a goal to restore all those dying dead and dying birch and aspen areas. Next one. This is just one example at Split Rock Lighthouse. It's about a 200-acre area, dying birch. Next slide. And the first thing they do is they go in and they brush out the hazel and maple to try to reduce the competition from the seedlings they're going to plant. Next slide. And then they plant. So this year already, they planted, that's my warning that I'm taking too much time. They've already planted 70,000 trees just in that one park alone. And they're planting deer-resistant species like white spruce and tamarack, but they're also planting white pine or white cedar that need a lot of care, obviously, because of the deer browse. And then they're planting, again, those temperate species that are predicted to do well. Yellow birch, red oak, and bur oak in the changing climate. Next slide. So, this is what we're trying to do. We're trying to take a very simplified forest that we inherited from the logging period of the 1800s, early 1900s, and to bring complexity back, to have a more diverse species composition, to have a greater range of age classes and greater structural complexity. Whether it's a mature forest or a young forest, diversity matters, complexity matters. Next slide. I just have a short story that I want to tell. Then I'm done. I want to talk about the loon because I'm standing under a loon here. And a couple years ago, in 2016, we had a knock on our cabin door from Phyllis Sherman. You know Phyllis. She is the loon guardian of Lumberjack Lake. And she came by and said, I have a loon out on the lake and it has fishing line. It's all tangled up in fishing line. I don't think it can dive. I don't think it can fly, and it can't drink. Could you help us? So Sonny and I got our canoe and a toolbox. We picked up Mona Hanson, and we drove out. And we were, yeah, you can leave this slide. We drove out, we found the loon, and in hindsight, I'm still not sure how we did this, but with a fishing net and a canoe and a kayak, we were able to get the loon into the kayak, get it out onto the dock, extract a fishing hook from its breast, and the fishing line that was wrapped around his bill and head, so his head was pressed to your eyes.
That's from Phyllis from what you actually got there. All the fishing lure that was on that loon. Phyllis dropped off a huge box.
And then we put the loon in the lake. The loon turned and looked at us, did a little yodel, and then took off across the lake. And here's Phyllis here, there's Yersinia, here's Nancy Seaton from Lumberjack Lake, that's Mona Hanson. And you can just look at Phyllis's face there. It was just a moment where it's just kind of that deep connection with that other world of plants and animals, and everyone felt it. And then that happened to be Phyllis's 80th birthday, September 16th of 2016, and she said that was the best 80th birthday I could ever possibly imagine. So, last slide, I guess there's one more after this. We also have a bird atlas that is not as reliable as the tree atlas, but it does paint a picture of what may happen to loons in Minnesota under a low emission strategy scenario and a high emission scenario. And if that temperature raises up into that 10 degrees or more, it's predicted that the summer breeding ground loon will migrate out of the state of Minnesota and migrate up into Canada. So it's hard to imagine the North Woods without having loons in their lakes, but this is what could happen. Now, if we remarkably curb greenhouse gas emissions, and there's no reason why we cannot do that. We can still have our blooms in summer. They may not be found in Michigan anymore, and they may be more common in northern Wisconsin, but will still be a stronghold in the northeastern part of the state. Okay, last slide. This is the first Boundary Waters canoe trip that Trusetti and I took together in 1986. So I'll just end on that slide. Questions? Yeah.
I have a question about the soil and the microbes in it. Is there any projection of what happens to those microbes especially the beneficial ones, as the climate changes?
Yeah. Well, let me just go back to the birch as an example. Just with the warming and the invasive earthworms that are eliminating the duff layer and just exposing mineral soil, what you're seeing, the ability of trees, particularly white birch, to take out nitrogen and phosphorus has been severely compromised. And that's one of the reasons that they're dying. So there's a specific example.
That's a mineral, but the living microbes.
Well, yeah, I mean, the microbes, if you're looking at like the mycorrhizal fungi, which actually I wanted to mention this book here, maybe you've read this book by Suzanne Schumart. It's called Finding the Mother Tree. This is a forest ecologist in the University of British Columbia who basically discovered the relationship between trees and how their root systems are all connected through a massive network of mycorrhizal fungi. And with those connections, trees are sharing resources with their own species and across species, and they're also biocommunicating with each other through chemicals that transverse through this mycorrhizal fungi. And this is the story of her life, how she discovered that, the resistance she had, and finally being noticed, and some pretty substantial changes in how we manage forests to maintain that complexity. As far as I know, not a direct connection in how the species of mycorrhizal fungi that may change as we get different species. I think that's still in the area of the unknown. But we certainly know when it comes to nutrient cycling, there's going to be a balance there, and the extent in which these trees are going to be able to adapt to a different way that nutrients are cycled, we don't know that. I'm aware. John?
So I have an ecology question from a non-ecologist.
Yeah.
I think Chapman was the one who shared this tidbit with me, but there was some literature some years ago about the impact of you going in fishing with earthworms and the impact earthworms have on soil transmission of nutrients, and then translated into not only soil chemistry, but then into the waters of the lakes. But it seemed to have an enormous impact on local and regional ecology. I don't know if that's in your bailiwick or...
Well, that's another area that Lee Frederick over at the university has really pioneered. It's hard to imagine, and it isn't one earthworm. And I'm not totally up on the latest with the earthworm, but there are at least 6 different species, and it's almost like a relay. So one species is expert at breaking down the coarse organic matter and relays it to another species of earthworms that breaks it down further and further and further. And then pretty soon, you've eliminated, in essence, the whole organic layer of the forest. And if you look at how adapted our trees are, just as one example, like red maple is projected to increase so much if you compare it to balsam fir. Red maple is very adapted to dry and wet soils. And balsam fir has to have a mesic, which is a moderate soil moisture. And it tends to require organic material to reproduce it. And that's because of earthworms and other things. That's just one factor of why balsam fir is not going to, it's going to be severely diminished probably in the future because of that whole dynamic with a species like red maple, which for whatever reason is much more adapted to some mineral and drier seabed.
But the earthworms would then be invasive, right?
Oh yeah, they're all invasive.
Earthworm.
There are no native earthworms
Right.
in North America. Yeah.
I was just gonna say, I like the book that you showed about the fungi.
Yeah.
There's a really cool video if you wanna watch, it's called Fantastic Fungi. And it's very interesting, it does that same, it explains the mycelium, network under everything, how it communicates and how it recalibrates how we think about nature. It's all so dependent on that fungi.
Yeah, I think one of the things that I love about this book, which is basically a memoir of her life, but it's really good science. And there's another book out called, I think it's called Entangled Life, but it's just on fungi. And it's the most fascinating book.
Yeah.
And they're both telling the story of interdependence and cooperation. And she uses it in her book as a metaphor for how we should operate as a society. And I think it's quite effective because if we don't take collective action and cooperate on a global scale, we're going to have immense suffering into the future. And what she's saying about our forest is that traditionally, forest areas have this competition model. And you see that a lot of in the history of our natural resource professions. Is that, okay, here's a tree as an economic value, let's go remove all the other trees and just grow the trees that have economic value. Because we think that trees just operate as individuals and they're just competing with each other. Well, she's demonstrating empirically and with incredible science that those trees are making up a complex adaptive system that's very productivity depends on maintaining all the parts. And so it is more of a model of cooperation and sharing resources and demonstrating how the forest ecosystem is one of as much cooperation than it is competition, and that these trees are actually sharing resources through this network of mycorrhizal fungi to other species that you would normally think they're competing with. And there are times when the fir trees in the Pacific Northwest are grabbing more carbon than they need and producing sugars, and so they're being shunted off to other species, and then a different season it happens the other way around. So anyway, so thank you for bringing that up. Yeah.
The overstory is another book that highlights that issue as well. I was wondering about the tamarack trees. Is there any antidote to that beetle? Any way of...
Yeah, there's a research project that's just starting this year. Entomologist at the University of Minnesota, I think his name is Dr. Akima. And he's doing two things. One of which, since it's a native insect, it does have native predators. And so he's looking at biocontrols. He's looking at the life history of that insect and trying really to pinpoint what is the cue that it's not getting now when it's time to shut down reproduction. And so he's trying to find those two things. First of all, is there a native species, there's a native wasp that feeds on it, there are various parasites that feed on that. And it's not an exotic species, so it's living in a certain balance. And so hopefully we have enough time, because we know even though the mature trees are dying, they're still natural regeneration. And the DNR knows how to seed those areas in via helicopter. And Tamarack does really quite well in the open area. So I think we have enough time now to find out to see if we can get that insect back into Vallows. And thank you for mentioning the overstory. I meant to bring a box of books, but the overstory is one of my favorite books. And it turns out that one of the overstory by Richard Powers, his main character, the forest ecologist, this is her. So, this was, well, it's modeled after her. Hopefully her ending is not as tragic as what was yours.
Excellent.
Thank you. Appreciate it.
Yeah.